This demonstration will show you how to create a tree canopy, a very high resolution tree canopy using the NDVI that was created using the NAIP image that is 60 centimeter and the nDSM. That's the difference between the digital elevation model and the digital surface model, which that's feature height. That equals nDSM is basically your feature height. So both of these were created in previous videos. So let's see. Let's just look at the data. The NDVI, these are the inputs. The NDVI, anything above 1, which is greenness. Anything above 0 is, anything above 0 is green. Anything below 0 is not green. Bare earth is kind of a pervious surface right there on the border, which can cause headaches sometimes, but it's out of our worry right now because all we're creating is tree canopy. But you can see some fields like golf courses, and that might not be a golf course, but some fields come out as green. A lot of fields do. So we don't want to count them as tree canopy. And if we look at our feature height, anything above 10 feet could possibly be a tree, but it could also be a building. So if it's above 10 feet and green, then it's most likely a tree. So let's look at this script here. And I have the nDSM. Remember, this is a 2017 nDSM, so this is not a perfect scenario. You would obviously want the nDSM and your NDVI to be from the same date, or very close to the same date. But for this purpose, it does work. It's fairly good. There are some minor manual editing that might not be necessary, depending on the accuracy level that you're after. For the most part, though, it works fairly well. So the nDSM, I'm going to reclassify. So anything below 10 feet is probably not a tree, and it's going to be classified as no data. This is because in raster calculation, if you have two data sets and either one of them have a no data, the output has no data. So if it's below 10, we're not interested. It gets dropped. It's definitely not a tree. So only above 10 gets a value. And this equals feature height 10. So feature height above 10 feet. We could use other values if we want to. And then for the NDVI, we've got the raw NDVI in here, and we reclassify that as values from -1 to 0 is going to be no data because that means they're not green and they're going to be dropped. And from 0 to +1 is possible tree canopy. We can manipulate those values too. And that's going to be called green greater than 0. So we can change that value. Now here I have this as just, I want to make sure that the nDSM is going to be using the same cell size as the NDVI, since that's the finest cell size. I think we created the nDSM at 60 centimeters. Not important right now. And the nDSM, the extent is the subset area. So I don't want to do any kind of analysis on the rest of the area, to reclassify only the area that's common. And then we multiply the two together. So just multiply them, and if one of them is no data, the output is no data. So let's go ahead and recompile, and we'll run that. And this is pretty quick because it's a pretty small sample area. So we get our tree canopy up here. I'm going to close this guy, and let's close the inputs and make this a really noticeable color. What's a good noticeable color? The top of that green is yellow. So we can see this is our tree canopy, and it looks pretty good. There's spots that I thought would have been considered tree canopy, but they must be shorter than 10 feet. That is a pretty good result. It's interesting. The shrubs, you can see the shrubs. If we did want to classify the shrubs, we could. There's other ways. Let's just explore that possibility. Stepping in, I have not looked at this. I don't want to do this video over again, so I hope this comes out to look the way I want it to. But I classified everything below 2 feet above 2 feet to 10 is potentially, so let's see what this looks like. So these areas here, yeah, so if we were to use above 2 feet, then they would get classified as tree canopy, but above 2 feet, and remember green, so it would have to meet both criteria. That's another day. For right now, this was just a simple above 10 and above 0 equals tree canopy. And remember, cautionary tale, the NDSM, it's very hard to get LiDAR data that's the same year as your NDVI, so you're going to have to take the pluses and minuses. You can pretty much assume, though, where it's accurate, it's pretty accurate. I mean, it looks very good. Where your questions come in are if features have grown since the elevation model has been created, and I don't know the answer to that. That's just the in this area in particular, these features must not be above 10 feet. They obviously look like they are scrubs or shrubs, but this is a fairly accurate tree canopy that we could do. We can calculate our values from this directly. Okay, that's it. I'll do another video on editing